We just had an awesome panel on building undisruptible warfighting installations, talking energy. And we're going to continue to have that conversation here a little bit and lean in, I think, into commanding energy. And we have our moderator, Shawn Charchan from CANA, here to moderate this panel. Shawn is a senior operations research system analyst at CANA, responsible for developing energy-related offerings and providing management, modeling, and simulation development. With 10 years of experience as a marine logistician and operations research analyst, Shawn has supported the operational energy community and developed analytical tools for service energy offices, OSD, and DARPA. He holds a bachelor's degree in quantitative economics from USNA and a master's in operational analysis from MPS. As a modeling and simulation analyst coordinator, Shawn plays a key role in CANA's projects with the Southern California Tech Bridge. And I'm going to leave it up to him to do the rest because he's the champ here. Appreciate you.
Okay, good afternoon, folks. So this is going to be a really interesting discussion, at least from my humble perspective. And it's because you've got different people coming from different perspectives here. And so my perspective is I've been working in the operational energy community since 2010. And we've got Eric Limpacher to my immediate left, followed by Chet Warner to one step over there. And so what we're going to try to do is, all with an eye towards commanding energy, we're going to share our unique perspectives, specifically the two panelists will, and I'll try to guide that discussion. And I'm going to try to, what I'll call, anchor it in through the lens of commanding energy and more specifically operational energy. And we had a very nice and productive discussion over lunch. And the point of the discussion was to give you all what I'll call actionable insights, to give you something, in the last panel, you heard a lot of stuff about a lot of systems that perhaps you consider out of your reach. So we're going to try to use the two panelists will try to use their unique perspectives to give you some stuff that's actionable while also providing you some valuable information about the specific equities that they represent, the assets they're trying to address, and the technologies that they're trying to bring to light. So when I say that I'm an operational energy analyst and I look to my left here and I say that, I'm not feigning ignorance, okay? I genuinely am just as curious as I suspect you all are about the technologies and equities that the two gentlemen to my left represent. So when I say operational energy, if that's the first time you've heard that phrase, we're really talking about from, in the maritime domain, Department of Navy, we are talking about the ship to the last tactical mile. So that involves everything from oilers, TAOs, TKEs, which you heard mentioned today, through things like the MV Wheeler. And if you don't know what that is, I highly encourage you to learn more about the MV Wheeler. You'll certainly hear about it in war games and O-plans and the like. And then lastly, down to things like microgrids. And I think it's rather interesting that you heard a stark contrast when the last group of panelists used the term microgrids, that they differentiated between what, say, a deployed Marine might think of as a microgrid when they talk about it in the context of what's aboard that amphib that they can actually deploy, let's say generators on down to the point of consumption, versus more of like a utilities-based microgrid, which is hybrid grids and stuff like that that you might find on an island archipelago. And so we're going to try to use very specific language to make sure that we don't conflate words for you all, for the audience. And even the word utilities, note that when you say utilities to, let's say, a Marine, it means one thing, utilities chief, et cetera, versus utilities in the context of the state of Hawaii. It means generally a very different thing unless you're like up in PTA doing an exercise or something like that. And I'll also note that Master Sergeant Dillard said previously today that the Marine Corps is very good at what he called tactical logistics, but he actually wasn't even comfortable going up into the operational level. And so what I'm trying to, the gap that we're trying to bridge here is all through the lens of commanding energy and command versus control. So command means authority generally, if you look at our pubs and stuff like that. So having the authority to then control energy, and that starts at utilities and production, all that stuff that we're talking about, then goes through potentially utilities-based microgrids onto bases and stations, then through to the ship, and then on to that last tactical mile. So we're gonna try to talk about things through the lens of the advances in technologies that these two gentlemen have made in the last couple of years. And then, so what I'd like to do is I'm gonna shift to them. So we'll start with Eric and ask him to talk about, I met Eric many years ago when he was with MIT Lincoln Labs doing a lot of advancements with technologies and the like there. And I'll ask him to cover what he's done, spend some time talking about that, where his interests lie now, and then we'll eventually move over to Chet, who is with Pareto Energy, talk about the same, and then I'll start into some questions, all with an eye towards achieving those goals that I stated a couple minutes ago. So with that in mind, let's take this opportunity, and we'll start with you, Eric.
Great, thanks very much. So just in thinking about my comments for this, this panel, I realized that my career has largely followed the evolution in technologies for Navy and expeditionary energy. I started in 2001 building some of the first microgrids around the country for installations. We built the microgrid that powered the gift shop on Alcatraz Island way back when. Then we built variable speed motor drives, went through the full mill qual testing, mill standard testing, got some products on board, CVN 78 and LPD 19. Then shifted to, I came to MIT Lincoln Lab and started working on tactical microgrids to reduce fuel consumption at forward operating bases in Iraq and Afghanistan. Stationary systems, but designed to be mobile, designed to be something that you could transport easily. And then over the last 7 years or so, the focus of the technology development has shifted to expeditionary energy. How do you produce energy in at the point of need? How do you eliminate or reduce the need for diesel consumption? And have seen the conversation shift dramatically with force design, EABO. 5 years ago when I was first exposed to a certain new technology, I came home, I was thinking, this is amazing technology. Do I stay at MIT, Lincoln Lab, and develop it there, or do I spin out a company? And at that point, Anduril hadn't even been started yet. TIU didn't exist yet. And I decided, I'm gonna stay inside the government and keep on developing. And now here I am, 6 months into starting my own company, trying to raise money, and it is really exhilarating to see the level of innovation, the faster speed at which the DoD is moving. Like, I can't believe I'm actually saying that. The faster speed at which the DoD is moving compared to my experience back in the 2000s. So things like working with ARC Orbit, addressing challenges for EABO energy, becoming a Krulak Center Fellow, developing a new operational energy concept, getting money from Expeditionary Energy Office and ONR to actually get technologies out has been really rewarding. So that's the good news, right? That things are moving faster. The technologies are shifting to meet the need that we expect to see in places like the Pacific. But there's still challenges, right? We're still, by and large, using fuel and using power conversion technologies that were built that are designed to produce mechanical motion, right? And in World War II, Korea, Vietnam, the energy that was needed was for mobility. Now, all the way from Gulf War with the use of GPS to, now in Ukraine, there's more and more demand for electrical power, for comms, for ISR, for unmanned systems, for infantry power. And we're still using, by and large, the same type of fuel, right? Diesel, JP8, JP5, and the same sort of mechanisms for generating electrical power, diesel generators, whatnot. And in order for logisticians to supply the end user, the tactical units what they need, I think we need to have fuels and power conversion technologies that are natively electric, right? Going from mechanical motion, going from combustion to mechanical motion to electrical power, there are 3 steps where you lose energy. And in places, in remote locations where energy is precious, we can't have that level of inefficiency, right? So there's propane, there's methanol, there's ethanol, there's hydrogen. There are all sorts of fuels and technologies like fuel cells and solar panels and batteries that are natively electric, and we need to be looking at whether it makes sense to have not just a single fuel concept for mechanical motion, but a single fuel concept for all those electrical demands. So hopefully through this conversation and maybe some of your questions, we can explore that idea between native fuels for mechanical motion versus native fuels for electrical energy. The good news is that the Marine Corps, it has utilities Marines. In my work with both the Marine Corps and the Army on tactical power systems, the Army is very good at prime power, at building up megawatt scale power generation in remote locations. The Marine Corps is honestly better at building and optimizing for efficiency tactical power systems at the smaller unit level because they have MOSs specifically trained to that. So that's some other piece of good news, and hopefully those Marines can continue to be trained on new technologies as we get more and more electrified systems out in the fleet.
Thank you, Eric. Okay, on to you, Chet, your turn.
Hi, everybody. Chet Warner here. I'm the Chief Operating Officer of Pareto Energy. We are a private sector company that works on early stage design of large microgrids, integrated energy planning, installation energy. Our heritage is coming from a little bit different perspective than the other two here on this panel. Our heritage goes back to community energy development. Our company was founded in 2004, working with the United States Conference of Mayors on a variety of energy challenges that large cities and communities were facing as it related to critical infrastructure. As we dealt into that, we ran into critical infrastructure, particularly the ports. We work with the American Association of Port Authorities and their port electrification program on facing the enormous challenges that are coming from electrification. So working from the shore to where the maritime meets and all the pieces that fit in between, things like electric tugboats, alternative fuels for ships, hydrogen production, electrified cranes and cargo handling equipment, hydrogen-based cranes and cargo handling equipment. Our role really is how do you optimize the design, how do you optimize the integration of all these resources so that you don't have the resources competing against one another for scarce availability of fuel sources. We also have a cooperative research and development agreement with the Naval Postgraduate School. We're working right now on a way to do this simulation and this optimization using a digital twin architecture that will allow for workforce training, cybersecurity, and operations optimization once the installation and the assets are installed. So that's the angle that I come from. I think what we're seeing is where does the installation energy meet the operational energy, that nexus point. I think that's a big challenge as you're talking about commanding energy, is those two functions are separated right now, and there's going to be impacts as we get more electrified resources and more alternative fuels at play here with installation development, whether at home or in the forward operating theater.
Very good. Okay, thank you, Chet. Okay, so again, all with an eye towards giving folks, participants here, something you can take action on. I realize that sometimes the technologies or as we heard about dare use the word bureaucracy in the last panel, they can seem like a big a beast and that there's no real tenable position to hold against those. And I had, in this great discussion we had prior to this panel, I had posited the question, well, where is there fertile ground that because of your experience and your exposure and your understanding of your respective technologies and the path that you've been on in the last several years, where's something that people can, where is there fertile ground for people to work that they could take away from? And I'm gonna actually pose that question in a rather nuanced way, which is to say, one of my favorite questions as an analyst is to ask, where is everybody asking the wrong question? And so I'm not limiting you to that. I'm just saying a way to flip that script a little bit is to say, You know, the question is not if the F-35 Bravo uses more fuel than its predecessors. It's how much, you know, ultimately with operational energy, it's about putting steel on target, right? That's what matters. So how much more fuel per kill does the F-35 Bravo use? And from that perspective, you address the question of efficiency in mission. So that's but one example of where we found everyone was sort of like asking the wrong question or barking up the wrong tree when it comes to that particular question. And maybe you guys have seen something similar there, or you just identified what I again will call fertile ground that people in the audience can start cultivating.
So, you know, so if we're talking about operational energy, one of the things that I've observed is people focusing a lot on batteries, right? Oh, we need better batteries, we need better batteries. If you look at the technology trend in battery energy density improvement, batteries have improved by 4x or so in energy density over the past 50 years. We're not going to have a battery miracle that triples the range of our drones or unmanned systems or triples the energy that a Marine can carry on his pack anytime soon. But if you switch to, let's say, hydrogen or propane, you can tomorrow have a tank that holds 3 to 5 times as much energy as the same size battery. Tomorrow, right? Plus batteries, you know, lithium-ion batteries, there's all sorts of concerns about transporting them, you know, in the embarkation challenges. So, you know, and the other good news is that, right, people are already using them. Like MARSOC uses the Stalker. The Stalker, made by Lockheed Martin, is a Group 2 UAV. It has a battery variant and a propane-fueled variant. The propane-fueled variant flies for 3 to 5 times longer. Why does the conventional force not use it? Because the fuel cells in those burn out after every few flights, so they're too expensive for the conventional force to use. But there are other fuel types, other fuel cells that last longer that, you know, could be used, right? So the solutions are in front of us, and I think people have been focusing too much on, as you said, you know, the red herrings, focusing too much on, you know, finding better batteries as opposed to using technologies that are available today in their existing platforms.
So I think this is a very interesting question, Shawn. I think glad you brought it up. This idea was sort of put to me by a general at the Energy Exchange Conference earlier this year, talking about the transition from combustion engines, from carbon-based resources to non-carbon resources or alternative fuels, whether that's hydrogen production, whether that's battery-powered. You know, he was explaining the idea that it's much easier to operate an electric motor and to service an electric motor than it is a combustion engine motor. But we have processes in place for how to service, how to do the logistics, how to bring the equipment in to service the combustion engines. We don't have that in place necessarily at this stage for the new resources that will be coming on. And most importantly, we don't have a framework and a uniform way that these systems will integrate at the installation level so that we can train people who are in the operational theater to work on it in the same context. And so I think the challenge is a scalable framework that is able to work and is technology agnostic and is able to simulate, that is able to throw workplace or workforce training scenarios at people, right, to deal with these various new technologies that will come on. And that has to be, in my opinion, an open source approach. It can't be a closed proprietary approach because you're going to end up with, you know, systems that can't communicate with each other, and that's going to just screw your logistics.
Okay, thank you both. Excellent answers and very helpful, and I hope that you all got something out of that and through both unique perspectives. And sort of, actually, it was a great segue. So you guys are looking at a trained acquisition professional, at least at one time. So I, too, have the acquisition stink on me, so I understand the process of identifying gaps and writing requirements to those gaps, and then later testing them and the like. And I offer that as a setup to the next question, which is, lately I've been embarking on some interesting projects where we are, rather than following what was identified in Act 101 to me many years ago as the typical process of saying, well, what do we need to do, and what subsets of that mission do we need to be able to prosecute to be able to have the effects that we desire, whatever those may be, and what gaps lie between us and full prosecution of the multiple submissions. And once you identify those gaps, then you say, well, let's write some requirements. And again, my information is dated here. So let's identify requirements that can help us to satisfy those gaps. And then we look to industry and say, we need to do this. And then I've seen examples where industry has come back and said that's actually beyond the art of the possible right now. That's not feasible from a physics perspective in one case to be able to accomplish those gaps. So the question is this unique endeavor that I've had the privilege of being associated with. We are not just looking to address gaps explicitly, but we are tying in this one case with Silicon Valley, and we're looking at autonomous electric vehicles that navigate to where the power demand is, and they bring 5G technologies and mesh technologies for information sharing. So they have exportable power, they're pretty cool. And we said, hey, these systems have already been developed for agriculture. And this is not an uncommon thing to do in innovation cells and whatever the buzzword is for the named entity that we're talking about. So in your two individual experiences, do you have any words of wisdom for people who are looking to not circumvent the bylaw required acquisition process, but ways that they can look towards the bleeding edge of technology, your two respective technologies that you're trying to champion, that they can work better with you so that either the requirements are better informed when they look to address those gaps, or keep their finger on the pulse of where those technologies are going, so that you don't end up perhaps looking to the wrong technology in one case, the wrong solution, or in another case, you're not looking to couple the technology with the knowledge, training, understanding, best practices, et cetera. So I throw that out as red meat for you guys to see what you can do with it.
Oh man, I have so much to say on that. I'm gonna try to stay focused. So I worked at a startup for 10 years, then worked at MIT Lincoln Lab for 11 years, and then now 2 startups relatively recently. MIT Lincoln Lab is the DoD's largest hardware prototyping lab. It's an amazing place, I love it, but getting parts made, even there was a painfully slow process. And I then, left Lincoln and joined a 19-year-old MIT freshman dropout at a company called Mach Industries, which has been in the news for a little bit. And first thing he did was he set up a room with 30 3D printers. I'm like, why the heck are we gonna need 30 3D printers? He's like, just watch. So DIU came in and he had a mock-up of the drone that they were building, and DIU said, oh, that's cool, but it would be better if it did this and this and this. So Ethan said, oh, well, you guys are at a conference here in Austin. Why don't you go back to the conference, come back in 24 hours. Pulled an all-nighter, redesigned the drone, ran all of the 3D printers overnight and all throughout the next day, and was able to build a mock-up of the drone that DIU had asked for by the time they came back for the next meeting. How does the DoD, train its, or not even train, empower its people to take advantage of those sorts of capabilities? Travis Horde sent me a photo of one of his enlisted Marines who was literally doing the same thing, right? Hacking FPV drones and 3D printing all sorts of add-ons onto those drones to do things completely outside of the normal thing that they were doing within the unit. So I think the best answer I've seen so far as to how the DoD's process takes advantage of that is some of that Astro Murray posted on LinkedIn a few months ago. And he said that instead of having a program acquiring a system over the course of several years, they should be acquiring certain capabilities under tranches. So it's still the same program, but the tranches are on a 1-year or 2-year cycle. And that way, Once you buy one tranche of drones that has, that meet the requirement, you can then buy another tranche of drones on a much faster cycle. I'm not an acquisitions professional, but that, that's the closest I've seen to an approach that seems to meet the sort of timeline. And then similarly with, the technology we're developing, where you could, in theory, you can rip a battery out of a drone, replace it with a hydrogen tank, a hydrogen fuel cell, make it fly 3 to 8 times longer. Having that sort of tranche process would enable us, with our new technology, to get in a year or 2 years rather than 5 years. So that sort of faster cycle within the DoD's existing process would be potentially enabling for new technologies like what we're developing.
Very good. Chet?
Yeah, so
Thoughts?
I think of coming from the electrical power side and the design side, and coming from the private sector, where my eyes glaze over at all the DoD acronyms and all the programs and all the requirements. I think we've seen a lot of work that's been done on engineering in isolation that doesn't take into account institutional realities that may or may not make the engineering possible to be implemented. I would say that's the biggest gap that we see from the outside, from the private sector. Shawn, you mentioned defining control. Authority is one of the elements in that definition. Well, in certain cases, if we're going to be integrating as much electrification as we are and distributing it optimally, we may be running into places where the DoD does not have the authority to be a public utility, for example, in order to make the most optimal outcome. So we're going to have to look at new business relationships, or we're going to have to look at new structures that can accommodate this transformation, right, to make sure that we have a seamless fighting force and the seamless integration of this technology into the operational field.
Very good. And actually, that does a nice job of touching on a rather profound point that the last panelist made a little bit ago here. And it was, again, part of our discussion over lunch, which is a real eye-opener for me was participating in a tabletop exercise, a TTX, that was based on a particular archipelago. And it was the first time that I had seen representatives from the utilities companies, private, public sector, to see DoD representatives, see everybody in the same room to try to prioritize DoD investment that could have an effect on public utilities. And it was, as you might imagine, it kind of bent my brain quite a bit because it was a new space for me. But to hear the nuanced complexities associated with what was trying to be accomplished. And one of the points that was made in the last panel really addressed that, which is training, right? Training, in this case, our own Marines and sailors, so they can first speak the language, right? Because as I alluded to at the beginning of this discussion, microgrid means one thing and means something wholly different to another, as does the word facilities. So just, I think that getting smart about, classic Sun Tzu move, right? Understand and I don't want to cast this as an adversarial role in any way, but just understand the language of the other entities could have gone a long way towards making the discussions in that tabletop exercise a lot more productive. So I thought that was worth mentioning because it was sort of alluded to here. What I'm going to do is...
Can I respond to that really quick?
Yeah, please.
So you're talking about the train, incorporating feedback from industry and the training necessary in order to be able to understand what they're saying and take advantage of their expertise. With my first startup, we had to hire a number of power electronics engineers, and looked all around the country, looked at where the best universities were that had power engineering. I remember when I graduated college, my degree was in electrical engineering with a focus on computer engineering, and I found a old large motor that the university had been using to teach power engineering 20 years earlier. And I said to my professors, well, when is Princeton going to start teaching power engineering again? And he literally laughed at me. And there I was, with my startup trying to hire power engineers. There were way more software people than I knew what to do with. And I ended up, sponsoring something like 36 H-1B visas for power engineers from India, China, and Iran. because those are the top 3 countries for teaching power engineering. And this was, back in the 2000s when renewable energy was first starting to take off. And lo and behold, China, India, and Iran well, maybe not so much Iran, but China and India made huge strides in their power grid and deploying renewables. And here we are with, the revolution in drones. And what engineering do you need to build the motors, to build the power converters, to take power from the battery to run the motors? You need power electronics engineers. Where are those engineers? Not being trained here. So that worries me. I'm encouraging my kids to become hardware engineers, not software engineers, because I think we need more people with their hands in the grease.
That's perfect. Okay, you heard it here first, folks. Well, at least second. I think Eric, did a good job. The other Eric here on introducing that idea. So I'm glad that did a nice job of reinforcing that. What I'm going to do is take a second to pause. We're just past the halfway point, and I'm about to kind of shift gears a little bit. So before I do, are there any questions about what you've heard up to this point? Okay. Yeah, please. No, this is a good opportunity while we're on particular topics that, sparked your interest.
Good afternoon, gentlemen. Chief Warrant Officer Kyle Babka from 1MEF, the fuels officer out there in Camp Pendleton. To your first point about the MV Wheeler, sir, the OPDS system, currently in a ROS status, and from my understanding, it was news to me as of this year. Down on Coronado, they don't even train. When I say they, EWTG PAC has cut that completely. With ACB1 and the Naval Beach Group there, a lot of the blue-green initiatives that we've done off the coast of California and as well, west of the international date line, reducing that overall footprint, having that capability, 1.7 million gallons at a time. We're trying to obviously disaggregate that Iron Mountain. So to your point, with that alternative energy, and I was at the DLA Joint Petroleum Seminar this past, I think, February, and a lot of those same briefs of what else is out there. What I'm asking you gentlemen is opportunities where we can connect with the Expeditionary Energy Office or Marcor Syscom to help push that gas pedal down a little bit farther to that point, right? And integrate those opportunities in some of our upcoming TEEP exercises for going into FY25. So kind of a formal introduction. I'll talk to you a little bit more offline. But if you could kind of talk through that process. I'm not an acquisitions guy. I don't have that background. So any insight that you can help provide would certainly be appreciated. Thank you.
We can certainly take this back to E2O, and I think you did a really nice job there of taking the MV Wheeler as an example, and depending on how important you think it is to certain plans or whatever, but it's like the ubiquitous solution, right? It's in so many plans and so many exercise plans and so many assumptions that it's going to be there, and between that and the Petersburg, right? Mothball status, not, but it's supposedly everywhere all the time. And it's an army of one. So it's a great example. And then I like how you flipped that and said, so we need to look for other technologies. And to reference your accelerator point, that was what we were trying to spark and provide everybody here, all you participants and listeners, was alternative ways instead of, well, there's the MV Wheeler, it's our solution, it's what we know, and we're already at the rev limiter in terms of using it as a planning factor, but just hit the accelerator harder. And then and we're trying to say, no, let's shift the focus. So I guess to summarize, I'll say that we'll make some connections with you after this with E2O, and I know that they've got opportunities for innovation and stuff like that you at the pointy end of the spear and your contemporaries will certainly be able to capitalize on. But I do, if you guys have any thoughts that come to mind based on that, I'll certainly, okay, good, yeah. Let's talk, man. Okay, very good. All right, anything else before we kind of shift here? All right. Oh, please.
This is probably a pretty quick one, but you mentioned propane a couple of times as far as fuel source. Were you talking about that direct from fuel to electricity or more going through kind of standard rotational energy and then to power production?
Yeah, so that's going directly to electrical energy. If you have, you need medical grade propane, so there's a scrubbing process involved. But the Stalker, the MARSOC uses medical grade propane to run a fuel cell directly to electricity. And I mean, there are all sorts of fuel cells, right? There are liquid-to-liquid fuel cells. When we were at Lincoln Lab, we were developing methanol and ethanol fuel cells that go directly to electricity. So there are all sorts of different types of fuels out there that can be run through a fuel cell of different variations to produce electricity natively.
Yeah, and that having a more direct fuel source to electrical energy connection, just in case that's lost on anybody, please look into the phenomena that we used to have where, you'd have a generator mounted right next to an environmental control unit with about a 3-foot electric cable. So just run how the physics works there through your mind, and you're converting liquid fuel right to rotational mechanical energy, rotational energy to electric energy, 3-foot cable back through reverse through the whole process again, and you just see it, and it definitely was a perplexing sort of situation. So the more you can cut that chain down, certainly the better. All right,
Yeah,
so
Shawn, I'd just like to add
please,
that there's another technology I'm aware of from a company called Mainspring that's called a linear generator. Sort of similar to a fuel cell, except that it has the ability to ramp up to meet load, and it's multi-fuel capable: ammonia, propane, natural gas, biogas. So that's another option that's also available called Mainspring Energy.
Thank you. Eric, did you have anything else?
So there are several companies developing those sorts of technologies. I guess as an engineer, I like to look at the numbers. If you look at the efficiency curve on a generator, at low load, it's like 5% efficient. Nearly 95% of your energy is wasted. And we gathered data on FOBs, both Marine Corps, Army, and Border Patrol in the Southern U.S. And the Marine Corps is actually the best because they had the utilities and Marines setting these things up efficiently. But Army and CPP, oh my goodness, they were running these things at 5% efficiency, 24/7, wet stacking them and destroying them, right? So if you have a fuel cell instead, it's 50% efficient across the board, all the way from low load to full load. And on top of that, it emits dramatically lower thermal signature and acoustic signature. So Army Ground Vehicle System Center, the people, the Army who do the ground vehicles, they did both thermal and IR and acoustic measurements on a Humvee versus the General Motors hydrogen vehicle that they developed for the Army, and found that they had something like I think a 300-foot detection distance, audible detection distance for the hydrogen vehicle. And that's with no engineering going into that signature, versus something like thousands of feet detection distance. So if we're talking, and then similarly with infrared, almost not visible at all for the hydrogen vehicle on the infrared because it was emitting almost no heat. And the combustion, the Humvee was glowing hot, bright red. So, when it comes to EABO, right, energy endurance is key, but also, avoiding detection. And so these other energy technologies provide not just, the ability to extend your range, but also the ability to avoid getting detected, under various reasons. So that's why I said we need to, I think, seriously consider a single fuel concept for electrical power, because there are multiple kind of compounding benefits that come from that.
Yeah, that's a really good point. And, there's something that happens. I'm glad that you brought up heat signatures, noise signatures, and the like. I had mentioned the autonomous electric system, actually, that the Marine Corps is looking at. It initiated in agricultural use. Four-wheel steer, four-wheel drive, extremely ruggedized, and it offers a tremendous amount of capability, and with its exportable power, with its 5G technologies, and it's a case of, and perhaps some of you guys are experience this. I've been so close to the problem of how can it, when coupled with a generator, enable a generator to operate more effectively, because instead of being down, you mentioned wet stacking, way down in the efficiency curve, you've got a 60 kW generator servicing a 2 kW load, and you run into all the maintenance problems and all that. Well, if you couple an electric basically a capacitor, right? But a battery source or something like that to that generator, you can enable the generator to operate at that knee in the curve in terms of near optimal efficiency for that particular generator. I had been so focused on that aspect of the problem that I had completely missed the heat and noise signature, which in the context of so many people, that's extremely important. So great. Okay, I feel a desire to bring us back to, this is called commanding energy, this panel. And I had mentioned that as I looked up this morning, the definition of command and control, that a key thing that jumped out at me for command in terms of commanding energy was authority. And, we briefly touched on, in both of this panel and the last one, the fact that a lot of times Marines are dependent on energy in which they just don't have authority over, right? So that could be you're pulling into a port or something like that. So what could be a solution? And thinking through it, perhaps the control pieces, and I don't mean control in the sense of explicit control. Perhaps with SANS authority, SANS command, you could have control. And by that I mean the control systems that control energy, AI augmented decision tools, information collection and distribution or sharing. And so bringing this, what I'm going to try to do is swing the pendulum back to your respective technologies and why you're really here, and leverage your expertise. Does anything come to mind when I talk about, again, control systems, AI augmented decision tools, information collection and sharing? And maybe that is found in the unique things that, whether you're talking about alternative fuel sources, right? Whatever it is that you guys bring, perhaps there's something that you could share with the audience here for their knowledge.
All right, so nerd warfare. One thing that we worked on when I was at MIT was the tactical microgrid standard. Standards are so exciting; they really, allow you to put rounds downrange. I'm joking, but what that did was standardize the data that was communicated between power systems to allow the collection of that data and reporting that data in order to make energy systems run more efficiently. So. I am encouraged that industry is starting to, like one of the largest distributor of protection relays in the United States is adopting that standard. It looks like it's been adopted for some energy storage systems for the Marine Corps as well. Having the data not having the data means that you can't make intelligent decisions. So it's up to us to make sure that data is available and then give the Marines the ability to make good decisions.
Very good.
And then on the in terms of commanding energy and making sure you have control over your energy sources, I'm working with ONR is funding an entity called the Kwajalein Atoll Sustainability Laboratory, CASL. It's based out in the Marshall Islands, and the Marshall Islands, they transport out the materials that they consume, and then the trash is not, it's economically prohibitive to transport it off island. Something like 25% of their land mass, which is precious because they have so little of it, is covered in landfill. So 50 years worth of garbage piling up. And so CASL has been looking for climate change reasons, but also for local economic reasons. So whether there's something you could do with that trash that is piled up. So my company is developing the ability to turn aluminum into energy. Aluminum has twice the energy density compared to diesel. So think of all those soda cans, all that packing material, all that dunnage, massive amount of energy that's just sitting there latent. So we can release that. There's another company that's that has a technology to turn plastics into naphtha, which is the precursor to plastics. And then Bar Rocket is working on taking glass and turning into construction material, concrete. So we've got pretty much everything covered there. So imagine 50 years worth of trash. That's a lot of energy that you can capture. For the Marshallese, that means economic development. It means money. For the military, it means being able to tap into energy sources that the adversary is not necessarily expecting, and that if the adversary wants to put a missile on a trash dump to deny us of that energy source, then they can go for it.
Very good. You know, it's good. I think that when people think of waste to energy, WTE technologies, or waste to fuel technologies, I think it's the first time I've heard somebody say that the adversaries aren't targeting, right? So that's a interesting way to put it, because you're just thinking about it almost as our adversaries would, which is our competitors, in that it's just a heap of junk, but there's value in it. So those are those creative ways. You know, I think, how many times have we heard the word innovation in the last couple of days, right? So those are those creative ways to recast things, reframe things. So that's not a heap of trash. That's a heap of energy just waiting for us. And that's the type of ideas that I think will help us to. Interesting thing to me is that there's probably conferences very much similar to this one happening amongst our competitors right now, right? And they're saying, well, how can we get more stuff and stuff like that? But that's the old speak, right? How do we get more stuff to the point of demand? The proper way to say it is, how do we use our stuff more smartly to, as we just heard about, to achieve the effects that we desire?
One other number that we ran that I found absolutely fascinating. Aluminum is a global commodity, right? And I just said aluminum has twice the energy density compared to diesel. Because it's a global commodity, there are commercial companies, traders, that will stockpile it so that when the price is low, they pull up their stockpile. When the price is high, they sell and they make a profit. There are stockpiles of this stuff all around the world. There's one in Vietnam that has something like 1.3 million metric tons of aluminum in stockpile. I looked at an estimate, the best estimate I could get from E2O, as to how much energy the new Marine Littoral Regiment will consume in combat operations. I looked at how much energy that stockpile of aluminum represented in Vietnam. That stockpile of aluminum could power the MLR combat operations. Again, obviously there's a bunch of conversion steps here, but just in terms of like high level numbers, for something like 30 years. It was as much energy as like all of 1.5 Red Hill fuel depots before Red Hill shut down, right? So there are energy stockpiles all over the place that we could tap into if we adopted the right technologies, and if we had the, that's a 20-year, 30-year time horizon, but there are some low-hanging fruit like unmanned systems, comms power that could take advantage of those sorts of energy stockpiles in the near term.
Thank you.
Yeah,
please.
back to your question about control, Shawn. I think I take it maybe quite literally, the control. I think of it in the context of, if you're going to show up and try to plug a boat in, try to charge an electric vehicle, you better be able to control the power quality, power waveforms that are coming off of whatever the source is that you're connecting to, so you can be sure that you have that power output. The electrified equipment is going to require power quality levels that are higher than some of the rough run diesel examples that we've been talking about. So you better be able to control that waveform, and the way that we do it, our company does it, is with power electronics, power converters, AC to DC to AC conversion, as was discussed in the last panel. So I think that's a way to control the waveform, control the power quality, to be sure that you can plug in, you can charge, that you can get the power you need into these systems so they operate.
Are there any innovations that people should be made aware of when it comes to those technologies? And my layman's reference would be, in the early days when I was camping, doing the RV thing, when Honda generators came online, right? The inverter generators. I mean, it was an absolute game changer because of the cleanliness, the efficiency, eco mode, all of that stuff. Is there anything that we should be keeping our fingers on the pulse for?
I think unfortunately the technology is not very sexy. It's been available for 20, 25 years. I think a lot here domestically in the US, the focus has been on low voltage inverters. A lot of the systems we're talking about will require medium voltage inverters in a medium voltage grid, either distributed, internal to an installation, or from a public utility grid, for example. Mm-hmm. All the standards exist in Europe for this. The IEEE has not kept up with that here domestically in the US. I think that's changing because of the demands that are coming from renewable energy penetration limits and forecasted, demand in the electric sector from electrification, from AI, which requires a lot more power for computing. I think it's about adapting what's already out there and utilized effectively in Europe and putting it into a U.S. context. That's what our CRADA with Naval Postgraduate School is working on trying to do, working with public utilities, working with installation energy managers, and hopefully eventually touching the operational energy theater when that framework is developed in a way where it can be adopted.
Thank you. All right.
I would highlight two technologies that I've been looking at, keeping tabs on. One is tight integration between the power conversion and the motor. So there's a company called H3X that's doing a really amazing job in terms of integrating those two systems together to provide really good energy density. That's relevant to things like, small aviation, sea gliders, where you want to have a really compact powertrain. And then the second is systems that are become natively DC, right? So, more and more stuff is being powered on USB. Going forward, larger systems will become native DC as well as we see more unmanned systems.
Okay, very good. There's the trends. Thank you both. Okay, and we are at time. Actually, do we have time for one question? We do not. I apologize. All right. There we go. Okay, so how about a round of applause for our panelists?
Thank you.
Thank you. Thank you, Chet. Thank you, Eric. Okay, very good.
Ladies and gentlemen, thank you for the opportunity to have them up here. Give them a round of applause one more time. They did a great job.